All right, so this is the check your understanding for 2.7 sine and cosine. And so what we're going to be using the power rule, the rules for derivatives that we learned in lesson 2526, and now we're going to be dealing with these as well. So I'm just going to go ahead and get started. Let f of x equal, and then find. Okay, so I need to find this, but before I do, I need to find f prime. So the rule for constants means that it should be 3 times whatever the derivative of that is. So 3 times derivative of cosine is negative sine x minus 2, which becomes negative 3 sine x minus 2. Okay, that's f prime. Oh, I love this shortcut so much better than doing it long ways. Find f prime of pi thirds. Negative 3 sine of pi thirds minus 2. Pi thirds is, sine is 1, is radical 3 over 2 minus 2. So I end up with negative 3 radical 2 over 2 minus 2. We can leave it like this, or you can do more crazy stuff. Sorry, that's not on the screen. That's the answer. I'm going to stop. Decimals, unless they ask, are dumb. Answers in simplest radical form, exact answers. Exact answers. That's an exact answer. Okay. Find the equation of the line tangent to y to this function. So I'm going to switch colors just so we know that. Find the equation that the line tangent to at. Okay. So y prime equals negative 2. Derivative of sine is cosine. Derivative of 5 is 0. So y prime at 4 pi thirds equals negative 2 cosine of 4 pi thirds. Using the unit circle, 4 pi thirds is in the second quadrant, so cosine will be negative pi thirds, 4 pi thirds. Cosine is 1/2 at 4 pi thirds, but negative 1/2. So this is equal to negative 2 times negative 1/2, which is equal to 1. That one I'm going to go ahead and check on my calculator. And I'm going to use the computer calculator just to check and make sure I'm not full of nonsense. And so I'm going to map 8x. I'm going to type in the function negative 2 sine, whoops, let's try again. Clear. Let's move my face. So, math 8x negative 2 sine x plus 5. Oops. Close my parenthesis. Oops. Sine x, close parentheses, plus 5. Okay. Take the derivative at 4 pi thirds. Actually, alpha y equals 1 4 pi thirds. 4 pi over third. Enter. So there's a small error here because that happens, but that's negative 1/2. I forgot the 2. I forgot the negative. I forgot a lot of things. So let's do that again. So bring it right back. I forgot to put the stuff in front of sine. So I'm going to second insert -2. Okay, see, 1. But this is why using the calculator is not always the most reliable thing. Our brains are more reliable sometimes than the calculator. Okay, so I got 1. List 3 intervals where g prime is positive given that cosine, this is our function. So g prime of x equals -8 cosine, -8 sine of x, intervals where the derivative is positive. So I know that sine is usually positive here to here, but this is, we're doing the opposite of sine. So the opposite of sine, where this is pi and this is -pi. Okay, so it's positive between -pi and pi, -pi and 0, and then it's going to be positive from 0, not at the endpoints, from 0 to 2 pi, wait no, not from 0, from pi to 2 pi, and I can go the other direction if I want, or I can keep going. See, it's going to be positive over here, and that's going to be pi, then it's going to be negative, then it's going to be positive again. You find the third one. Okay? I found the 2 easy ones. Yeah, third one is going to be 3 pi to 4 pi. Or if you went the other way, -2 pi to -3 pi. Because from there to there it'll be positive. Negative, excuse me. Alright, last problem. So it says evaluate this crazy limit. I'm not going to. I'm going to cheat. No, I'm not, but I'm going to use my brain. So I've got cosine right here, and I have x right here, okay? So I think this might be f of b minus f of a over b minus a. And that's, so notice how I'm taking the limit as x approaches pi halves or as b approaches a. So that's what I think this is. I think this is a form of the instantaneous rate of change that we've been dealing with for a while. And we're going to use a shortcut because we're going to recognize what that is and do it faster, because doing that limit will take a long time. So I must be trying to find the f of x must equal cosine, and I must be trying to find f prime of 2 pi. See how, because what is cosine at 2 pi? It's 1. So f of a and f of a, and a is where I'm trying to find the value of. Okay, all right, so let's just do the derivative. F prime of x equals negative sine x. So f prime at 2 pi is equal to negative sine at 2 pi, and sine at 2 pi is, I believe, yeah, it's 0. So negative sine will be 0 as well. Wasn't that fun? That's kind of fun. Moving on to the second one for ln and e. So check your understanding, give an exact answer. So f prime of x is equal to e to the x minus 3, derivative of that is 3, and then derivative of ln, still a little blurry, derivative of ln of x is 1 over x. So f prime of 3 equals e to the 3 minus 3 plus 1/3. And I'm done. That's an exact answer. It said give an exact answer. I'm not doing it anymore. Now I could put these two together because, you know, they're numbers. I should put those two together. So negative 9 over 3 plus 1/3, right? 3 is equal to negative 9 over 3 plus 1/3. And so then I have e to the 3 minus 8/3. There you go. That's a better exact answer. Okay, That would be the multiple choice answer. This would be an acceptable answer to your teacher. Multiple choice? Correct. Both are good. All right. What x values, if any, does e to the x have to horizontal tangents? Explain. This is a different question. What does it mean for the tangent line to be horizontal? The tangent line is horizontal when y prime of x is 0. So the tangent line is horizontal when the derivative is 0. Horizontal y prime equals 0. Okay, so let's go ahead and take the derivative. Y prime is e to the x minus 0. Is e to the x ever equal to 0? No. No. E to the x is never equal to 0. It approaches 0 as x approaches negative infinity, but it doesn't actually get there. So, no. That's my answer. You can explain it in your own words. All right. Ooh, another limit. Let's see if we can do this one fast. I've got h plus 3 plus h, 3 and 3. Oh, okay. What am I trying to find? Can you tell that this is asking you to do the derivative? We're trying to find, let's say, g, because there's no g, of x. G of x is next. Let's call this h. H of x is ln x, because look, ln, so h prime of x equals 1 over x, and so I want to find h of 3, which is 1 over 3. Done. And this is why we want to recognize what it's asking me to do, so I can take a shortcut. H prime, excuse me. So this limit's equal to 1. Very important to recognize the shortcut. Give the equations of the tangent and normal lines. So again, tangent means the same slope. Normal is perpendicular slope to this curve at x equals 1. So it wants equations of lines. Equations. So we're going to use this slope form. Y equals m parentheses x plus x1, x minus x1 plus y1. And again, that's something from, we did not do a good job with this in CPM. I don't think they do a great job at introducing us to actual issues with, they depend so much on slope intercept form, so they don't really introduce that well. That's okay. Let's find g prime, because that's the slope, which is equal to 1 over x plus power rule 6x. Okay, g prime of 1 is 1 over 1 plus 6 times 1, which is equal to 7. Okay, so that's the same slope, and then my perpendicular slope will be negative 1/7. Okay, so let's go like that. So y, so normal, or let's do tangent first. Y equals 7, parentheses x, plus 1. Wait, minus 1. That should be minus 1. And then y. So I need to figure out what y is. Oh, I need to find g of 1. ln 1 plus 3 times 1 squared. Natural log of 1 is 0. 3 times 1 squared is, so this is 3. So I need the point. So it's 1 comma 3 is my point I forgot to find. Okay, so plus 3. There's my tangent line. Alexa, dismiss. And my normal line will be y equals negative 1/7 x minus 1 x plus 3. And that's it. And then we have number 5. In the xy plane, the line blah is, where k is a constant, is tangent to the graph of, what is the value of k? Okay, so tangent to the graph. So y prime is 1 over x. And so when I plug in, so these need to be equal at some point. Now I'm thinking. I'm not sure. So I know their slopes are equal, so maybe I should find the slope. Let's find the slope. So 9y equals 3x plus k divided by 9y equals 3 over 9x plus k over 9. And so the slope is 1/3. So my derivative needs to equal 1/3. And so 1 over x needs to equal 1/3, so x equals 3. So x is 3. That's my x coordinate. That's important. And tangent. So the x coordinate is 3. So my slope is 1/3. Okay. I need to touch y 1 over x. So I need them to be equal when I plug in 3. Okay, I can do that. Sorry that I'm not doing this well, because this is going to kind of go right here. So this needs to equal this when I plug in 3. So the natural log of 3 equals 1/3 times 3 plus k times 9. So ln of 3 equals 1 plus k times 9. Ln of 3 minus 1 equals k times 9. And so k equals 9 times ln of 3 minus 1. And I'm going to stop right there. There's the value of k. That's an ugly, juicy mess. So I'm just going to check 5 with Desmos. And so I'm going to have the ln of x. There it is. And then I need let's find, just for grins and giggles, make sure I have that right, f of 3. Okay. Alright. I want to plot that point. Actually, so I didn't really want to do that. I want to do 3 comma f of 3. So you can see, there it is. That's the point I want to be tangent to. Let's go ahead and put this funny line in. So I have negative 3x plus 9y equals this funny number I found, 9, parentheses, excuse me, parentheses, ln 3 minus 1. Oh, hey, there it is. I just closed my face. There you go. See how it's perfectly tangent? There you go. Alright, messy, but done. So I hope you had a great time. I'll talk to you guys soon.